Welcome back. In this lesson, we're moving into the last section of chapter 6. We're moving into section 8. We're going to talk about inverses of relations and functions. When we're talking about inverses, now you've seen things like this before, like the inverse of a square is a square root. The inverse of a cube is a cube root. So you've experienced this before without even realizing that this is a vocabulary that we use. An inverse is the opposite. Okay, it undoes an operation. And you've seen this a lot in math just without knowing the technicalities behind it. So what happens? Well, when you're talking about a relation, what happens when you take the inverse is you have a point AB, it flip-flops, okay? It undoes it. So it goes to BA, all right? It just switches the X and the Y values. So now we're not going to get into this deeply until part B, but just because something is a function doesn't necessarily mean its inverse is also a function. Again, we're going to talk about that in section B of this, but just what I want you to understand is this concept of X and Y. If this is your relation, notice they flip when you take the inverse. Okay, same thing. Notice this table. The x's compared with the y's. Notice when you take the inverse, notice how each of them flips. They stay paired with the same thing, but you flip the x's and the y's. Now, what does this do visually? What does this do graphically? Well, it actually ends up making a mirror image across the line y equals x. When you do that flipping, you get an exact replica across that line x equals y. Okay, they mirror each other. And again, that's going to become important more later on. In this section, we're just going to focus on the basics. I just want to get you to understand how to create an inverse. And then in the next section, we're going to talk about that graphical piece and how to determine if the inverse is a function. So again, right now, the important piece here is determining what is the inverse. So for the inverse, I'd always use y instead of f of x. So often you're going to see f of x equals. It's so much easier if you switch that out with y right away because it's just a different notation. And then it makes it a lot easier to find. So what we're looking for to find the inverse is we're going to be switching the x and the y. So I'm going to get x equals 2y plus 6. So that's the inverse equation. However, when we're giving equations, we never want to just leave it like that, do we? So we're going to resolve for y. We're going to take this new equation and we're going to solve it for y. So I'm going to subtract the 6 over, divide by 2. So my inverse, y is going to equal 1/2 x minus 3. Okay, that is my inverse function. Okay, now, again, just to emphasize that graphical piece, I want to show you that is what the two lines look like. Okay, this is my original line right here. This is the inverse. And again, I just want you to notice that relationship. It is an exact reflection over the x-axis, or over the line y equals x. All right, what about this next one? So again, I'm going to cross out f of x, and I'm just going to call it y. And now I'm going to rewrite this, switching the x's and the y's. So now I need to solve for y. I need to undo everything that's being done to it. So I'm going to multiply that 3 over, and I'm going to add the 8 over. So my inverse function is going to be y equals 3x plus 8. All right, and graphically what that looks like is this. This red one is my original function, my original line. Here is my inverse. And again, I just want to emphasize to you that it is an exact replica when you cross it over the line y equals x. All right, let's look at this example. So again, I'm going to cross out f of x and use y, because now I'm going to flip-flop them. X equals the cube root of y plus 7. And now I need to resolve for y, so I can represent it as a true graphable equation. Well, first I have to undo that cube root. Well, to undo the cube root, I'm going to cube both sides. Cubing both sides will undo the cube root, but it's going to end up cubing the x. And now I'm going to subtract 7. So my new equation, y equals y cubed, or x cubed, minus 7. So again, giving you the idea that a cube is the inverse of a cube root. All right? And graphically, what does this look like? Well, here is my original function, which again, you know what a cube root looks like. And then you know that a cubic looks like this. Okay, so the shapes shouldn't surprise you. But again, the thing that I find interesting is notice that perfect mirror image. Notice how it perfectly reflects across that line y equals x. Our next one, again, our goal, flip x and y. So I'm going to get x equals square root of y plus 3. And now my goal is to resolve for y, to get y by itself. So first thing I'm going to do, I'm going to subtract that 3 over. And now, oh, I'm sorry. And now I'm going to square both sides to undo the square root. So I get x minus 3 squared, and it undoes the square. So my equation looks like that. That is my inverse. So let's take a look at that. Now, here's my original, a square root function, which again, you know how to draw. And then its inverse. Now, it goes over the line x equals y, just like it should. But I do want you to notice something. Is even though the equation shows that my inverse is a parabola, I want you to notice you actually only end up with half of a parabola, okay? So this is a really unique situation that only happens when you have some of those domain restrictions. This is the first one where the domain isn't all real numbers. So because of that, even when you take the inverse and we get this inverse relationship, that domain is still actually going to be restricted. So note, even after we find the inverse, it's not the full parabola, it's only the parabola piece when x is greater than or equal to 3. So just something very interesting I want you to note, that when you have domain restrictions in the original function, those domain restrictions still end up applying when you find the inverse, okay? So just a little fun fact for you to be careful of. All right, looking at this, so again, I'm going to replace the f of x and just use y instead to find the inverse, I'm going to flip-flop the x and the y. And now I'm going to have to re-solve for y so it's written as an equation. So I'm going to subtract my 5. And now to undo that cube, I need to take the cube root. So I'm going to get the cube root of x minus 5 equals y, or for those you'd like the y to be first, here is your inverse. You're always just working on undoing any operations. So graphically, what does that look like? My original was a cubic, so of course my inverse is going to be a cube root. And when I look at that line, y equals x, I can definitely see that mirror image still happening. Last one of our notes. I know you must be getting tired of doing this. So again, to find the inverse, flip-flop the x and the y. Now, to undo a square, you have to square root. Now, the interesting thing about this, okay, the really, really interesting thing about this is remember, whenever you square root in an equation, you get plus or minus. And then obviously, it undoes the square piece. So even here, even in inverse functions, that idea still remains. You have to make sure that you're still following the rule that if you square root in an equation, you get a plus and a minus. You absolutely have to follow that. Now I subtract the 1, so the y is by itself, or for those of you that like the y first, there is the inverse. And of course, graphically, my original was a parabola. So the inverse relation is a parabola on its side. And you still get that perfect mirror image over the line y equals x. All right, so a lot of good stuff in this one. All right, a lot of good graphical stuff, equation manipulation, all of it. So I want you to now write me that summary. So again, summarize how to find an inverse. I'd like you to comment on that domain restriction that I mentioned. Okay, reiterate that to me. What is that about? And what's that plus or minus about? Why did that come about again? So there's a few little tips on what you can put in the summary to make sure you fully understand everything that I've put in this video. Once you have that summary done, again, just make sure you have everything written out and then come back ready to do your practice work.